Hello, this is a video about solving applications questions. Okay, this is an area/volume application of calculus, and you're using calculus to find the maximum values of this box. Okay, so what the question wants, also what the question describes, is a square has four equal corners cut out of it. That's like the little dotted X lines there, and there, and there, and there. Okay, and it's folded to form an open rectangular box. They fold this side in, that side in, that side in, and it makes a box. Okay, so with that in mind, all these questions are leading you to answer the final question, which is what is the maximum volume of the box? So let's go through them in turn, and we should have all the tools we need to find the maximum volume of the box. What's the biggest amount a box can hold that follows these rules of being 12 centimeters and having these corners cut out? Okay, so what's the range of possible values for x? Well, x can't be like 22 because it's cut out of a side that's 12. And if you look at it, the maximum volume of x is if you cut all the way and you've got just x, which should give you, for a, x is greater than 0. So x is bigger than 0, and x is less than 6. Okay? So B says in terms of x, find an expression for the height. Okay, so the height of this box is just x. Okay, so BI is just going to be x. Okay, because when we cut this out and fold it up, the folding up gives the box height. Okay, double I, we've got to find the length. Okay, now the length is going to be the side on the bottom. So it's going to be this side here. We'll call that the length. Okay, and that's going to be y minus, that's going to be 12. The entire length of the side that it could be. Take away the two x values that are cut out. Okay, and fortunately for us, because it's a square, the width of this box is the same as the length. So it's going to be 12 minus 2x as well. Okay, so that's B done. C, write an expression for the volume in terms of x only. So what this has guided us through is these are our constraint equations. These are the equations that stop the box from being as big as possible. Okay, without these rules, the box could be 50 million. Okay, but the fact that all the sides are cut out of a 12 centimeter square means that it can't be beyond a certain size. Okay, so now we're going to find the volume equation, which is the one we're going to get the derivative of and maximize. Okay, so the volume is length times width times breadth. That's the volume of a box, each of the sides. And question B is taking us through each one of those. Okay, so it's just x, or the height of the box, times 12 minus 2x, times 12 minus 2x. Okay, so now we've got, I'll distribute the brackets and then times everything by x. Okay, so with algebra, V equals 12 by 12, 144, minus 12 by 2 times 2, 24x. That's just and then minus 2x squared, which is 4x squared. Okay? And if you expand those brackets, you'll get that. Then all of that stuff is times by x. So now we go through and times each one of these. So our volume equals 144x minus 24x squared minus 4x cubed. And that's what we're trying to maximize. So that's the answer to C, and that tells us the equation we're trying to maximize. So now we've got an insight into D, which is maximizing the answer to this equation. What number for X gives us the biggest number for V in this equation? Okay? So to do that, we find the derivative where X starts going from bigger to smaller, that maximum turning point. Okay? So to find the derivative, we just go V equals 144, and the X goes away, minus 2 times 24, which is 48x, because we take one from the 2 on the index, then minus 12x squared. Okay, now I'll just take this down so I've got some more working space. Okay, with this, we're trying to now solve it for 0. So instead of V dash, we've got 0. Okay, so 0 equals all of this stuff. Okay, I'm going to divide everything by 12 just to take out the highest common factor. So it's 12 outside of 12 minus 4x minus x squared. Okay, now I want to use the null factor law to find the smallest answer for this. Okay, so two things that add together to give me 4 and times together to give me 12. Okay, it's because I'm trying to recreate these brackets or factorize these brackets. Okay, so 12 is 2 times 6, and there's a difference of 4 there. Okay, so I can be 2. Now, because this x is a minus x squared, we need to factor that out as well. Okay, so we just put a minus out the front. Minus 12, because we can do that. Then we end up with x squared, just timesing the x squared by minus gives us a plus 4x minus 12. Okay, the two things that times together to give us minus 12 are minus 2 and minus 6. And minus 6 is the bigger one, so it wants to be a plus. So x plus 6, x minus 2, minus 12. Okay, so now I've got those two things. We know that x can be negative 6 or positive 2. Okay, now this looks like we've got two answers to the question. Okay, but bringing back to the question itself, you can't cut a minus 6 out for x. Okay, that's actually the minimum. That's the smallest volume that you can make. Okay, we're after the maximum. Okay, the 2. So our answer is 2. Okay, which is the maximum volume. Sorry, our answer is x equals 2, which will give us the biggest volume for the box. Now it says, what's the maximum possible volume? Okay, so there's a last little trick in this question. it's not good enough to give us a 2. We need to calculate the volume of the box when x equals 2. So here we can go back to our volume of the box equation. Okay? So we'll go 2 times 6 minus 2 times 2. Sorry, 2 times 2 is 4. So 12 minus 4, 12 minus 4. 12 minus 4 is 8. So it's 2 times 8 times 8. Eight by 8 is 64. Double it and you get 128. So 128 is my final answer. Okay? And what I want to show you too, just to finish off, is to give you a little bit of faith in the rightness of this process. Let's just pretend that it gave us a wrong answer, that it gave us 3. For your work, we can still create a box, but the volume's going to be less than 2 because 2's the ideal. Okay, so let's just pretend x equals 3. It'd be 3 times 12 minus 6, which is 6, and then 12 minus 6, which is 6. So 3 times 6 by 6, which is 36. 3 times 36, 108. Less than 128. And what this process has given us is faith that 128 centimeters cubed is the maximum that you can make out of a box like this. Okay, that's the process. Good luck with the questions. Bye, guys.